So, hello everyone. Once again, welcome back. So, in this video, we learn about bitwise operators. What is the bitwise operators? So, simple means bitwise operator is the operator which work as the binary numbers. Means that we are adding all the things, all the manipulation and the all the things we are using in the we are we are using, yeah, we can say we can performing in the our binary code, yeah, our decimal, yeah. If I get the decimal value, we convert into the first compiler convert into the binary. After then all the manipulation is known as the bitwise operators. So bitwise operators, so we have around 5 or 6 bitwise operators. So first one is the bitwise and where simply we perform the AND operator, and after then we have the bitwise or. After then we have the complements. Bitwise complement, simple means he's convert into our binary code into the two's complements. After then we have the right shift operators and the left shift operators. So let's start. First I take the this one, bitwise bitwise or. After that we cover the bitwise and. So first I take the bitwise or. So I open my VS code. So first what I need, I simply include the header file, include stdio.h. After then wide main. What I do, I simply use the bitwise or. So in the bitwise or, I earlier said first we convert the our numbers. Let's suppose we take two numbers. First one is the 5, not 5. I take the first number is 25 and second number is 14, 12. So first of all, I'm writing here. First of all, we convert the both value is the into the binary. So what is the binary number of the 25? 25 binary number is 11001. And what is the binary number is of 12? So 1100. So this is all about our binary number. After that we are using the bitwise and. So bitwise or. So bitwise or, in bitwise or may simply when adding two value. If one if we adding which, if we adding 1 into 1, he become 1. If we adding 1 into 0, he become 1. We simply do the addition of the number. So let's do the addition. So what we do here simply we, when we adding this particular number, let's enter it. And here I added this both number. So if I add 1 and plus 0, so he become 1. After then, sorry for that, after then what we do, we simply add 0 plus 0 become 0. After then we add 0 plus 1 become 1. After then we simply add 1 plus 1 become 1. In the or operator, when both value is true, we simply return true. When both value is false, we simply return false. If any one value is true, we simply return true. So here both values true. 1 is represented as a true and 0 is represented as a false. So here you can say both value is 1, so we simply return the 1. So here 1 is printed. After then we have one another value, which value is the 1. So 1 here we consider as the 0. So when again doing the same thing, 0 plus 1 become 1. So this is all our, sorry, you can say this is our, this is our, I write here comment, this is our addition of the binary representation, and this is our addition of the binary representation. After that we simply print it, not print it, we convert in this particular value into the decimal number. And after then we de- decimal number. After once we simply return it. So let's try to solve this type of, let's try to code this. So what we do, simply we take the two value int 25. So 25, sorry, int a equals to 25 and int b equals to 12. After then what I do, we simply use printf. In the printf, we print the decimal value. So that's why we using integer value. That's why we using %d. And here what I do, we using the using the or. So here you can say we use a or b. So simply in the printf, I simply write a or b, and after then I run it. So here you can say 29 printed. If you add this value, then answer is the answer is the 5237 and 2 is 36. 36. This is also the 36 in the integer form. But here we convert into this particular number. This particular a is equal to binary number. When again we convert to this b into the binary number. Again we doing the same the logic. When adding the two binary number, he give me the answer as the 1100, and when he convert into decimal, he give me the answer as the 22. So this is all about the bitwise or. So let's I comment this, also comment this, not I comment this. Let's I what I do, I simply again I use bitwise and. So in bitwise and, if both value are same, not set, if value is bitwise and, simply addition of the multiplication of the two numbers. So here what we do in the bitwise and, simply what we do, simply add this particular, divide this particular number. I take that same number, I consider as the same number. So when one multiply one, he give me the output as the 0. And when 0 multiply by 0, he also give me the output as the 0. So in the two field we are, and when 0 again 0 multiply by 1, he give me the output as the 1. After then we have 1 multiply by 1, sorry, here give me the output of the 0. So again we have 1 multiply by 1, then he give me the output as the 1. And again we multiply by 1 multiply by 0, he give me the output as the 0. So here is the, this is our binary format. Binary, sorry, when we convert this number into decimal, so he this number is the 8. So 8 is the printed onto our console. So let's use the in the bitwise and, we use the and operators, sorry, and operators, and simply run it. So when the bitwise and operation is doing, the output is the 8 is printed on our console. So let's run it. Let's save it and run it. So here you can say 8 is printed. So this is all about the bitwise, all about the bitwise and bitwise or. Let's go to the bitwise complements. So what is the bitwise complement? Let's remove the all the things. So what is the bitwise complement? Complements. So in the complement means we simply convert two's complements. So what is two complement? So suppose we have any numbers. Let's suppose we have values 1 0 0 1 0. So first what we do, we convert into the ones complement. So what is the ones complement? Simply where we have 0, we simply return as the 1. So let's convert to here. In the first position we have 1, so simply convert into the 0. In the second position we have 0, so simply convert into 1. Here with the 0, this convert into 1. Here you can 0. Here in the fourth value is the 1, to simply convert into 0. Here the fifth value is the 0, to simply convert into 1. So this is all about our ones complement. Simply how to find the ones complement? Simply where value is the 0, simply put the 1. Where value is the 1, simply put the 0. Simply you can say the we using the not operators. In the not operation, if the value is true, return the false. If the value is false, then return the true. So this is all about the ones complement. We here I calculate the ones complement. After that, how to find the twos complement? So in the twos complement, simply what we do in the twos complement, we simply plus we simply add by ones. So when we add the When the add into the ones complement by 1, he give me the output as the twos complements. So when we add the value is the 1, so 1 1 equal to 1, 1 1, sorry, 1 1 equals to, here we adding the additional of the, not binary additional, here not be using the addition logical, or we add simply add the value. So when add the 1 1 become 1 0, so simply what we say, write the 0 and 1 is carry, so 1 is going to here, and 0 1 become 1, so he simply return the 1, sorry for that, 1. After then we simply write the 1, because 1 and 0 1. After then we again have 1, so simply write the 1. After then we have the 0. So this is our, twos complements, twos complements. This is our, yes, twos complements, sorry for that. This is our twos complement, this is our twos complement. And when we convert into the decimal, when he convert it to decimal, he give the output as the 14. So this is all about our twos complement. So let's write the code. So what I do, I take the same example. Here this value of the decimal is 18, so simply I write int a equals to 18. After then what I do, simply print in the printer, I simply use percent %d. In the percent %d I simply use a's complement. After then control s and run it, so sorry, here you can say a's complement is 90. Sorry for this is not our a's complement. Here you can say a's complement is 90. This is all the process how to calculate the a's complement. Here the output is the 19. When we convert the a's complement, he give me the output as the 19. So I'm not getting the minus 19 here when we convert in the value, because we are considered as the 8 position. So when we consider at 8 position, so here you go 1 0 0 0 0 0, and here also 0 0 0. When we convert into 8 lines, he become 1 1 1 1 1. So this is all about the one, all about the how to convert the twos complement. This is the basic method how to convert the twos complement. And here is the he how to use the twos complement. Here using these symbols, and after then we simply write the a, so it's converted the our code into twos complement. Let's take the exam, let's take the output as the 1. He simply return the minus, not minus 256 something, so minus 2, sorry, minus 2. When I convert into minus, he give me the minus 2. Let's convert 2 complement 18 and control s. Here 2's complement is the same as the 1's complement. When first one he is converting to the minus 1, and after then he convert into this. So this is all about the how to calculate the 2's complement. After then let's go move into further. Here is the one, we have the right shift. After then we have the, sorry, left right shift. After then we have the left shift. So let's first talk about the left shift. I removed it all. So what is the left shift? So let's take the example. We first use the left shift. In the left shift, what we do, we simply move the further. Let's suppose we have the input, any input. We have the input 5. When you convert into the binary, he gives the 1 1 1. And what we do, we simply use the left shift. So when we using the left shift, we simply in the left side here, so not in the you can simply say in the here left side, we simply add the 0, not here. In the left name is the left shift, but we use the here in the right side, so we in the right side we simply add the 0. In the right side we simply add the value is the 0. So this is all about the our left shift. If I use the left shift 1, here I using the left shift 1, then we adding the value as and the right side 0. If I add in the left shift 2, so in the right side we adding the value is 2. So this is all about how to calculate, how to add the what is the left shift. Let's take the example int a equals to 5, and I take another example int b equals to 9. So what I do, we simply printer in the printer. I simply use percent %d. In the percent %d, what I do, a left shift 1, we simply a left shift 1, we simply 1 0 we add into the right side, and after then we what I do, we left shift 1 and run it. So here you can say, let's I move it, simply use the slash, and after then here you can say, after completing the left shift, he in 5 become 10 and 9 become 18. When you write the left shift, when you convert into the 5 into left shift, he become 10g, or when we convert into decimal, so the output is 10. Let's I use the left shift 2. Here I using the left shift 2. He going to the left shift 2, so here is the output is 20 and 36. This is all about the left shift. Let's talk about the right shift. In the right shift, here I'm writing right in the right shift. In the right shift, let's take the example is the 5. In the right shift we using 1, so the value of the 5 is in the binary format is 101. In the right shift, simply add the values here 0. So when we add the value in the top position here in the 0, this one is removed by here. So when the 1 is removed, he become 0 1 0. 0 1 0, so he becomes 0 1 0. After when he becomes 0 1 0, is the 0 1 0 convert into the binary format, the decimal format, and print it. So let's give the example. Here I simply write in the printer, here I use slash, and here I simply write printer. In printer, simply write right shift. In the right shift, what I do, I used again the same variables a and b, a, and simply write percent %d slash n for new line, and here I simply write a right shift 1 and simply copy it and simply control V, and here we write, after that save it and run it. So here you can see the our after applying the right shift, left shift 5 become 2, and after apply the right shift in the 9 become 4. If I using the 2 right shift, 2 value shifted. So here you can say 2 values shifted, then we adding the here is the 0 and he become the 1. When the 2 using the 2 right shift, a become 1 and b become, let's run it and save the what is the v become. So a become 1 and b become 2. So this is all about the our comparison of, sorry, bitwise operator. Bitwise should simply use the in the bit manipulation. So this is all about the bitwise. I hope you like this video. If you like this video, please share with your friend and also subscribe my YouTube channel. Thank you for watching.